Hi learners, good morning. So today we are going to see the topic elementary row matrices. So it is just nothing but elementary row operations that we are going to learn in this chapter that you have already learned in the beginning of this unit as well as in the previous unit when we learned about this row echelon matrices and all. So we are just going to see what exactly is an elementary row matrix and what is an elementary row operation. Okay. So elementary matrices are nothing but which is the result of applying only one row operation. Remember, it is just only one row operation to a square matrix, and definitely that matrix should be an identity matrix. Okay. So in such a case, we call it as an elementary matrix. So in this equation, you can see that the capital letter E is nothing but an elementary matrix. So here the small letter e is the elementary row operation that is being performed on an identity matrix. When you talk about elementary row operations, you can see that basically there are three types of elementary operations, which is one is the interchanging of the positions of any two rows, and another one is multiplying a particular row by a non-zero scalar, that is quite important, which is a non-zero scalar, and finally replace a row by the sum of the row and a scalar multiple of another row. So these are the three elementary row operations that you must know. Now just like other matrix questions, like the what do you say, you already saw in the row echelon form, reducing to the row echelon form, here you can see that you need to identify whether this question is an elementary matrix. So as you know already that elementary matrix is nothing but the result of an elementary operation on an identity matrix of the same order, isn't it? So here this is your question. So this should be definitely an identity matrix of 3 by 3 order. So I'm going to have an identity matrix having a 1 1 1 and the principal diagonal, and if you're performing a elementary row operation as r2 is given as minus 3 r2, you will be getting the value as in the second row it will be replaced, the 1 will be replaced by minus 3, and as you can see this is exactly equal to the question. So in this case we can say that the whatever that is being given in the question is an elementary matrix. Now what about this question? Here in this one we can definitely see that the second row is completely 0. So there isn't any sort of row operation that will give a 0 unless and until if we subtract it from a previous value. So here we cannot subtract it from 1 here, and definitely you are not going to get a 0 here. Only if you multiply it with a 0 you'll be getting a matrix that is being given in the question, and hence we can conclude that this is not an elementary matrix. Now these are the questions that we have already done in solving of linear equations, where you can simply deduct the matrix form of the matrix form from this linear equation and just perform the row operations, and finally you will be able to solve it as like this. Okay, so you'll be getting the values of z and all these things. Thank you.